All right, so it's 11, so I'm going to begin now. Hey everyone, welcome to nTop Live. My name is Gabrielle Thelen, and I'm on the application engineering team at nTopology. In today's session, I'll be showing an application of nTop that I know would have really helped me greatly in some of the projects that I worked on before joining the nTop team. So I'm actually going to jump to this other instance of nTop. So the implicit model within nTop platform opens the door to like a robust modeling environment, no matter the complexity. And I'll demonstrate how this modeling technology can be leveraged from an automation and automotive perspective. So here I have a simple block, and it's acting as a part nest to this taillight. I couldn't find an example of a really complex taillight, but if you look at many automotive taillights today, they've gotten much more complex as far as their outer shape, whether it be for aesthetic or performance purposes. So in addition to that, I mean, this is just kind of the shell of that taillight, but there's a lot more components that go into it as far as screws, studs, and other aspects. So the assembly and testing of these taillights involves welding tabs, driving screws, testing lighting connections, etc. In many cases, it involves an operator loading the parts into a part nest, and then the assembly and testing operations are automated, whether it be through like robots coming in, welding these tabs, or other actuators performing these operations. All in all, it's really important that these taillights remain in place and that they remain securely during these operations, and that the outer surfaces don't get damaged or scratched. So this is a workflow I created that creates a part nest for these taillights. And as you can see, we have this simple block, but it molds nicely to this part nest here. So it's just a matter of bringing in this CAD part, converting it to an implicit, and then filling it, and then it's just a matter of like a Boolean subtract, which is an easy operation with an nTop platform to get this nice conformal mold here. So the reason I say that nTop would have helped me greatly in previous projects is because I worked on a project in which I had to design part nests for taillights, which involved servicing operations in my CAD tool. And if you're familiar with servicing in CAD, it can be a very tedious and frustrating operation, especially if you're surfacing for a much more complex part. And so for that project in particular, I was able to create a part fixture, I was able to surface the part, but then there was part changes to the tail light, and I had to update my model. And you would think that would not take a lot of work, but even a slight change would really be a time sink. So I'm just going to show you how we can do this in nTop platform and how quickly it is actually. So I'm going to jump to my CAD tool, and let's make some part changes here. So we have that tail light, and I'm just going to do just a couple of simple changes. So let's actually increase this. Let's do 135. And let's maybe change this to, just increase this radius to 20 millimeters. So just a couple of changes here, and then I'm just going to save this to my desktop. Let's save it. Parasol is just my preferred file import type, so I'm just going to save that part. And then if I go back into nTop platform here, I'm just going to open up my import part, select this folder, and then we got our new taillight. And so you're going to see that part get loaded in. We're going to start converting to implicits here. And then, so within this workflow, all I have to do is import my part, and the workflow will rerun and create a nice conformal part fixture. And so we're going to, again, seeing that part get loaded in, the getting converted to an implicit, and then we're going to see these other blocks start to regenerate. And again, it's really integrated workflow. So so there's our implicit. We're going to see the part getting filled. And so once I fill it, I'll be able to simply Boolean subtract it from this initial block here to create this conformal mold. there's just a couple of other variables that I designated here, length offset and width offset. So when you have these part nests, sometimes it's necessary to have other fixturing at the top or clamps. And so having those offsets just gives more space for more machining operations on the sides there. So yeah, again, it's just a matter of kind of waiting for the calculations to perform, waiting for this, but other than that, I don't have to touch anything. And as you can see, we're starting to create that conformal mold, just waiting for the render here, and we'll get a nice shape. So you'll be able to see how we can take this workflow and again, apply this workflow to more complex parts. And I'll show you, here's our part. Let's remove the tail light and still a nice little mold here that conforms nicely to that new geometry. So again, taking the same concept and applying it to something more complex here. So got another, this is actually like the back of a motorcycle, but still tail light. You can see kind of these different tabs here. And these are the tabs I was talking about that involve like welding in. But again, we have this more complex part. I'll remove that view and you can see we get a nice conformal part fixture here. The nice rounded areas, conforming nicely to ensure that it's secure and that outer surface is not going to get damaged or scratched. So that was a cool application of nTop that I wanted to show off, especially because it was something that really resonated with me in some of my previous work. So before I open up to questions, I just wanted to remind everyone that this video is being recorded and will be posted later on our YouTube site if you want to go back and reference it. So let's get to questions if anyone has any. Another really great thing now with our latest release is that I can actually take this nice mold here. And if I want to bring it back into CAD, I can do so with our back to CAD abilities. And lots of cool stuff there. So question, after performing the cut, what would you do next? So for just speaking on experience from the previous project, we actually created these molds with, they were urethane part nests. And so we would do the surfacing, make this nice part nest. And then there were a couple of offsets here in which we had other clamping fixtures here. So actually in this case, this is something from an nTop perspective, I could take this back to CAD, bring it into my assembly or my design for, so what I did is I actually designed an assembly cell that automated the testing and assembly of these tail lights. So once I got this nice conformal part nest, it'd just be a matter of taking it back to my assembly more for just like form and fit within that assembly there. Can I show the exporting to CAD? So yeah, I could do that. I can show you the steps to what we could do here. Let's go to something that'll be a little bit quicker. So this is kind of a recent, well, not even a kind of recent addition to platform. So I'm still kind of getting used to the certain knobs that we need to turn here. But essentially, we're going to do like a mesh from our implicit body. Going to remesh it here to get something a little bit nicer. try. And then, so once I do this remesh, we have a new block called quadrangulate mesh. And essentially, I'm going to take this remesh surface, bring it into my quadrangulate mesh. And again, this is a new block for me, so there's some different inputs here that I'm sure you'd play around with. But here we have our quadrangulate mesh here. There's could be some refining done. You can see some of these edges, some knobs that we need to turn. But then it's just going CAD, body from mesh, bringing that into here. And then we get our CAD body that we could bring back into our CAD system by just putting, using a block called export part, I believe. Yes. And then bringing that into here, designating a file path, and then getting it back into CAD. That mesh workflow is helpful, no problem. Yeah, again, those are kind of a couple of those blocks are new, so learning more about those inputs. But again, if you pop open that question mark within each of the blocks, we got tells you each input and then input descriptions here. So, and I'm sure we're going to be coming out with a lot more support documentation as far as kind of those series of steps there. So if there isn't any more questions, I think I'll start wrapping it up. Please make sure to continue attending these lives. Again, coming up with cool applications Monday, Wednesday, and Friday, and a lot of good stuff there. And then, like I said, with the latest update, back to CAD, but we're just continuing to bring out really cool stuff. So definitely recommend continue attending, following us on LinkedIn, YouTube, and continuing to bring out more content there. Oh, said, could you please repeat which file type you prefer to import? So I'll just kind of speak to that. Let's go to import part here. So we can import like SolidWorks, neutral file types, step, Parasolid, SolidWorks, but then also the native Creo NX. My preferred file to import is Parasolid. It's just my go-to. I think a lot of tools have their preferred file types, and Parasolid is mine. Yeah, so I'll wrap it up, but if you have any more questions, please feel free to reach out, and I'm happy to answer them. But thank you for attending.